Welcome back, everybody. Build Stuff 2022, day 2 in the afternoon. Thank you all for coming back after the amazing lunch, and I'm sure Hannes is going to keep us awake because he's spectacular.
I'll try.
Thank you so much. Just before we get into the talk, again, a nice reminder, on the back of your badges, you have that bingo card. If you visit the sponsors, you can get stamps, hand your card in before 4 o'clock tomorrow, and you can win some awesome headphones. And stuff like this is really impossible without sponsors, so please be nice to them. Okay, so our first talk of the afternoon, we have Hannes. Do I pronounce your last name correctly? Lowette.
Lowette, yes.
Lowette, okay. Hannes Lowette. Developer, coach, father of 3, and guitar on the line breakers. So this evening at the after party, well, middle party, I guess, because it's on day 2.
Yes.
Hannes is going to be on stage playing his awesome homemade guitar, which seriously, you have got to see this thing. I'm going to let him say what it is, and without stealing too much more of your time, take it away.
Right. Well, now I do have to mention the guitar. It has an inlaid Visual Studio logo in it, and people will come after me. After the gig, they'll always come to talk to me. It's like, is that a sticker? It's like, no, it's actual wood. And then they ask me who made it, which is me, and yeah, that's how that happens. It's a good way to get in contact with fellow guitar nerds. I love nerding out about a bunch of stuff, one of them being aka.net, which is why we're here today. And it's amazing to be at Build Stuff, because this is the conference where I started my speaker career, and I love coming back here, and I've been here every year since. But for today, I'm first going to tell you a little bit about the example problem domain that I'm going to use for this presentation. And I'm going to walk you through the general design decisions that I did when I built this, and why I chose aka.net for the implementation, and how all those things fit together. I'm going to show you a little bit of the code that you would need to write if you want to build a CQRS DDD style system with aka.net. And hopefully in about 42 minutes, we will wrap everything up, and you will have a little bit of an idea on how to work with this. So what are we building? We are building beersender.net. Why are we sending? What did I want to build this? We had a bout of conferences at the end of last year, and it ended in Norway, like where Henriksen is from here. And there, the world went on lockdown again, and it was not the first lockdown, but it hit me really hard. I was really sad. I was just getting back to seeing people and connecting with fellow nerds all over the world. And I was bummed out sitting at home, and I figured, like, I need to do something fun. And I'm from Belgium, so my idea was, I'm from Belgium, what do we do best? It's like make beers, right? That's what we do. So I think, like, okay, if I take these beers and I put them inside a box and I ship them to my friends, then everybody will be happy. And Lode changed that to Borat, because that was supposed to be like 2 friends. So he edited my slides without me knowing. Thank you. Now, at least, how did I execute on this idea? I went to the store and bought like 200 beers, because friends of mine run this microbrewery that make the beers in the front, and they also gave me these boxes, and they had room for 24 beers, so I figured, like, I need to buy a multiple of 24, because I'm not going to send half empty boxes. That would be wrong. So I ended up with a very nice selection of beers, and I packed everything up, put shipping labels on it, and my expectation was, if I give this money to UPS to deliver these boxes, they're gonna bring them to my friends in Europe, right? It's a reasonable expectation. I was wrong. The reason I was wrong is, apparently, Hannes Lowette, do not have a license to ship alcohol through UPS. It's not even a customs thing. Because I'm allowed to, I know this because I work for a company that makes custom software, so I'm familiar with a lot of the rules. I am allowed to ship alcohol up to a certain limit as a gift. That is not a problem. But UPS doesn't see it that way, so they asked me for extra information, and then without further notice, they just dropped the boxes back on my doorstep. Well, at least half of them. The ones that were inside Schengen actually got delivered. The ones that went to Norway and the UK and Switzerland, they all came back. So yeah, you get stuff like that, returning to sender, and I was sad. And it ended up being really painful. It's like you're tracking the shipments, They get delivered back to you. You send a bunch of emails to them to figure out why. You try to get your money back. Talking to UPS help desk is a hell in and of itself. You get connected with people who can only see the same information that you can see on the tracking page. Very helpful and total waste of time. So I shipped them through a different carrier. Then they made delivery attempts that were actually not made. So I know this because I talked to my friends. So they said that they tried to deliver a package in Bristol, but it wasn't delivered. So by June, I mean, this was supposed to be my New Year gifts to all these people. By June, all the boxes were delivered. So that was absolute hell. So we need like something better. Sending beer is tricky. Making boxes is fun, but like tracking everything and sending it, that is actually hell. So we need an app. And that app is going to be beersender.net. Now, why is it called beersender.net? We're not savages. We're not going to write it in VB6. Okay? Stop calling your applications .net if they're written in .net. We've had this for more than 20 years now. It's cool. You can call it beersender. But when I was thinking about this, like, okay, I want to apply some proper software design when I'm making this. And DDD for me started when I tried to read this book. Any of you tried to read the Blue Book by Eric Evans? Some of you did. Did you get through it, like all the way on first try? It took some time. Okay, I just read through the first half and then read Von Vernon's book and then came back to this one. But I mean, it's not an easy reading book. Those of you who have tried, if you're attempting this and you find it hard to swallow, that is fine. A lot of people have gone through that. I'm not going to summarize the whole book. You have to remember a couple of key concepts that we are going to apply in this talk. Like on a high level, what DDD is about is figuring out where the boundaries inside your software system is and within which part of your system something means the same thing, right? So you try to figure out what the language is that you're going to use both in the business and in your code, preferably your ubiquitous language. And if a person means the same thing inside a certain context, but like an address may mean something else depending on whether you're dealing with shipping or with invoicing or whatever. So defining those boundaries and defining that language is one part of it. And we try to get it into very expressive code that almost reads like business people can read it as well. So the root of reasoning about what happens inside your software is an aggregate. An aggregate is like the smallest context where you're actually going to reason about commands coming in and events being raised. And these patterns these books were actually written from an object-oriented perspective. But if you look in the DDD world, how people are doing these implementations, they often move towards commands and event message-based systems, applying patterns like CQRS and event sourcing. And that is what this talk is about. Now, I mentioned commands and events. Just to get a quick context, a command is something, it's a request that we have for the system. Like, please perform this action. We always write them in imperative form. For instance, send beer. And whether this command succeeds or not, we do not know until we get events back. And like the beer has been sent or the beer failed to send, that could be events that result from that command. And an event is something we cannot change because it has already happened. It happened in the past. So it's just a fact, a stated fact, right? So when you think about commands and events, it's really easy to talk to business owners or domain experts, as we call them in DDD terms. It's the same thing. If you talk to your domain expert, it is easy to reason about business processes because that's how the world works. If I send an invoice to you and you don't agree with the invoice, I'm not gonna update the invoice. The paper is already on your desk. There's no way for me to retract that. What I can do is I can send you a credit note. So we are going to make compensating actions on top of that, and there's a whole bunch of things that have already happened that we're not gonna try and change. So that's the whole idea behind this events thing. And then if we look at the CQRS pattern, which matches really well with the DDD way of thinking about things, is that we can have, what CQRS basically says is you're going to split the read side of your application to the write side of your application, right? On one side you have all your queries, on the other side you're going to have all your commands. And when commands go into the system, they don't fail. They're just a request. Okay, so that goes in, and the commands can change the internal state, right? Anything on the read side cannot change state. It's just going to query things, right? Queries do not change state, and commands do, but don't return results. That is the whole idea. But if you take it a little bit further, when people talk about CQRS, they're almost always talking about a pattern that looks a little bit more like this. It's like commands go in on one side and we have some kind of write storage. And the write storage is where we will validate what will happen with this event on the current state of the system. And then decide based on that which events are going to come from that. And we're going to raise these events and move them over to the read side, where the events will be used to project all the read storage and prepare that for the queries that might be coming in. And the advantage of having this system is that you can performance tune both sides independently, and they're loosely connected, right? And the performance tuning on the read side is ideally you can have every query hit a single table on an index and be snap fast, right? That is like, you have a question? Yes, and then it raises an event like this failed. So if I do a command send beer, that is a valid command, but the package might not have been closed up and I might not have a tracking label, so I will raise an event that says sending beer failed, no tracking label present, whatever, right? So the thing is, like, it's always valid to send a command into the system. What we do with that command, it might not change the state, but it might raise an event like, hey, this command failed because you tried to do something that's invalid. Okay? Cool. But the cool thing is that if we can performance tune all this, and I need to go forward, if we combine this on the command side, if we combine this with event sourcing, it becomes even more interesting. And event sourcing is a pattern where we're not going to store the current state of the system, but we're going to store all the events that led up to that state. Like the common example for this is a shopping cart, right? You put product A in, and then you put product B in, and you take A out again because you saw in the recommendations like, oh, we also carry product B, and that's going to be a better match for what I want. The state of your shopping cart is going to be like product B is in there. But the fact that you first put A in and took it back out, that is very valuable information. And that would be lost if you only store the state. But it is not lost if you keep all the events. And the philosophy is we can always project the state from the events. And reading 1,000 events from the database and projecting them in memory is actually a lot faster than developers usually think it is. Because it's a single table select on even if you're using a SQL database, you can use something like event store as well. But it's a single table select, it comes back, and then all the rest happens in memory, and it's really fast. Usually if you do a join across 3 tables, that will be a lot slower than projecting 1,000 events. So we will not store the state, but we will store the events, right? That is the whole idea of doing event sourcing. And if we put all of that together, the design that I wanted is I wanted to have a CQRS system where on the command side I was doing event sourcing. I wanted to have very clean aggregate implementations that if I would ever get tired of Akka.NET and maybe want to host it in something else, I could reuse my aggregates. That's something I wanted. And I wanted to have really nice and clean tests that I can ideally reason about with my business, my domain expert. So then we come to Akka.NET. Why did I choose this for my implementation, and how does it help us? Any of you already familiar with Akka.NET, or? Okay, no hands, that's good. Well, a few, like a little bit. Now, what is Akka.NET? It's a .NET port of Akka on the JVM, which is a project made by Lightband. It is at the moment in a little bit of a storm because they changed their licensing model. Akka.NET is not affected by that because it's not built by Lightband. But it is an implementation of an actor model. And what actor models do is they try to model software the same way that the world works. We will have actors and they will communicate through a message-driven reactive pattern with each other. And it gives us high concurrency. That's all you need to know for now. I'm going to show you the most important parts that you need to know from a programming perspective. Like all the building blocks inside an actor system are actors. And actors are just simple classes. They need to inherit, inherit from a base class. And these actors, they hold their own state, aka fields or properties. I mean, it's not more complex than that. And they also hold their own behavior, being functions, methods, whatever you want to do. And they have an inbox. And to the inbox you can send messages, and they are processed in order, one at a time. And this one at a time part is very important. It's very powerful, because you know that there's always going to be only a single thread active on an actor at any given time. Which means you don't need to care about locking. You know that when you're changing your own state, that you are going to be the only thread who is doing this. And this allows us to scale this out really well across many, many threads and many, many actors, because every actor is going to work only on its own subset of the shared state. Now, this guaranteed single-threadedness is very important because it makes writing actors in highly concurrent systems very easy to do. Now, how does that look like? What does that look like in your code? You inherit from untyped actor, and you implement the onReceive method, right? And objects are coming in, but they're actually typed, so you can inspect the type of message that you're getting and act accordingly. Like this is the untyped version. There is a strongly typed version that will feel a lot more comfortable for all you C# developers in a couple of slides. So don't get worried too much about the interface. But this is the simplest one you can do. And all of the messages from the inbox are just going to be dispatched to the onReceive method one by one by one. Okay? Then the second thing is messages, right? They don't need to implement anything or inherit from anything. They are just POCOs. They should be immutable, but please make them immutable. Like C# record types, perfect for messages, right? Then you know that they are not going to change after you send them across. They might get serialized and deserialized if they cross a machine boundary. As long as the message stays on the same node of the cluster, it's just going to be an object reference being passed around, so you could exploit that, but don't do that, right? They claim that on a beefy server you can do 50 million messages a second. Normally now I would claim that on my 6-year-old laptop I can do 4 million messages a second, but that broke yesterday and I'm presenting from my iPad, and that can probably do more because it's one of the fancy M2 ones. So, but no, I mean 50 million messages a second being processed on a single server is definitely reasonable. And then when we want to put all of this together, and now I'm showing my age because this is the Metallica album that I grew up with. It was all downhill after that. The actor system is your puppet master. It's going to take care of everything. It will instantiate your actors for you. It will manage all the inboxes. It will manage the event bus because there's a pub subsystem in there as well. And it will do all the heavy lifting, like the thread scheduling for us. It will use the thread pool to maximize your machine's capabilities to schedule all the messages to all your actor instances. So that is luckily not too hard for us to use. Like Aaron and the people at Petabridge have done all the heavy lifting on that. But creating an actor system is not more than calling actor system.create and giving it a name, right? We now have an actor system running. But I told you that the actor system is responsible for creating our actors, right? It manages the life cycles of our actors, which means that we will never hold the actual object reference to this actor in hand. So we have to tell the actor system how to create our actor for us, and that happens through props. And the easiest way to explain props is this is a pointer to a constructor. It's like you're going to use, in this case, the empty constructors. This takes a params array of objects, so you can pass all your constructor parameters to this method. And it will look for the matching constructor and call that to instantiate your actor. And the actor system will remember that it created your actor with a certain set of props. So even if for some reason, when there's memory pressure, the actor system decides to take your actor down, if you message it again, it will spin it back up with the same props. Which is a very powerful system. And then you call system.actorOff. You give your actor a name, and it will return you an iActorRef, which is not a reference to your actual actor. It's just a small object that allows you to talk to it, right? And if on your Akka.NET node you have enabled networking and TCP connection, you can actually pass this around across the network, and that object will keep working even after it has been serialized and deserialized. So these ActorRefs are actually pretty amazing and pretty powerful inside the whole system. And you can use them to talk to your actors by calling the telnet, and that just puts a message into that actor's inbox. There's not much more to it than that. But once these systems grow, we need to get into a little bit more of a complex management of actors. We cannot all create everything at the top level. And actors live in a hierarchy. And there's 3 actors that are always there: the root, the user, and the system actor. All the thread scheduling stuff and whatever is under the system node, you normally don't touch that. Under the user actor is where you are going to create your actors. So the one that we created in the previous slide is actually going to live here at the top level. It's going to be /user/myActorName. That was what was in there, right? And your position in this hierarchy defines your address. The one on the bottom right is called /user/a2/b3. Pretty straightforward. So if you want to create child actors, and notice that here we do have a receive actor. I don't think this slide is animated. This is a strongly typed version of the actors. So this is not the untyped one, but the receive one. And then we can just create handlers for every message type that we're going to expect. And if we don't have a handler for it, that message will go to the dead letter queue, and you can monitor your system for dead letters happening. Now, if this message, the create child message, comes in, and we actually want to do something with this, we can actually do a context.actorOf, and context is what is going to create a child to this current actor, right? Context has a lot of stuff in it, like the sender of the message and things like that. But if you call context.actorOf, that is going to go further down your hierarchy in a tree. Now, why is this hierarchy? Oh, it is animated. Cool. So those are all the things I talked about. Why is this important? It's because of supervision, which is the fault tolerance mechanism that is built into Akka.NET. And I know for a fact that Henriksen has a lot of kids here. So, Glenn, tell me, if you go to a supermarket with your kids, who is ultimately responsible for anything that happens? You are, exactly. And it's exactly the same way with actors. If your children fuck up, you're responsible. To put that in a more clear programming terms, if your child actors throw uncaught exceptions, it is the parent's responsibility to implement a strategy to deal with these exceptions. And that's called a supervisor strategy. You can take different actions. You can either resume, which means it's okay that this happened, throw away the message, try again. You'll do that with your kids if it's not too bad. Or you can say restart. Restarts means we're going to preserve the entire inbox, we're going to restart the actor, and then reschedule that same message again. It's like let's try again, like let's clear state and go again. Escalate means I don't know anymore. I'm going to ask my dad, because what did they do when I fucked up like that when I was a kid? And then there is stop. Stop means like, okay, this means that this actor is done. I'm going to kill it. Don't do that to your kids. It's like, this actor is done. The fact that this failed is disastrous. There is no point for this actor to keep existing. We're going to clear away the inbox, clear away the actor, and do something else, right? And you can either apply this to the one failing actor or to all of your children. The second becomes important when, for instance, you cut a large workload into many different parts. You delegate all the parts to multiple actors. And if the whole workload is invalidated by one failure, then you clear out all the children and start again, right? So that's supervision. Also, that is not that hard to implement. We override the supervisor strategy method on an actor, on the parent actor in this case, right? And we just return the strategy that we want. And the strategy, in this case, this is the one-for-one strategy that applies only to the failing child. We can actually inspect what the exception is. So we will actually get the exception from the failing child, and we can expect what the context on that is. and decide what we want to do and return the right directive. And in this place, you can also keep track, for instance, if you want to implement exponential backoff, or if you want to do like 5 retries but then fail disastrously. This is things that you can do in supervisor strategies. But I've been talking about like killing off actor instances and restarting them with the same props, but that means that all your state is gone, right? All the fields that were in that object, they will be gone. And that's where persistence comes in. Akka has a persistence model. It will put on the overhead of writing to a database or any kind of data store. And how that works on an actor that we want to persist is that when the actor starts up with its props, we actually check the snapshot store if there is a snapshot for this actor. And then we restore the snapshot. And then we will query all the events from the event store that have happened since that snapshot was taken, and then those get replayed on the actor, and only then will it start accepting new messages from the inbox, right? And that takes a little bit more code. So this is an actor that is split out over multiple slides, but the things that you need to remember, there is base classes for persistent actors, and they do need a unique persistence ID inside your entire actor system, because that's going to be the key that they query the data stores with. I always group all my state in a state object. It makes snapshotting a whole lot easier. And now we no longer have a receive command handler, but we have a command and a recover handler. And a recover is a message that is coming from the event store, and a command is one that is coming from the inbox. And you might want to handle those a little bit differently, because you don't want to repersist something that has already been persisted. That is basically the reason that there's 2 different handlers for those. And snapshots, I'm not going to dive into that too much today, but remember that saving a snapshot is not something that happens in thread. It is something that is delegated to the system side of your actor system, so you can subscribe to the success or failure messages. Your snapshot message will be like, please save my snapshot, and you can get results back through messages. And the persist method is actually the most important one. It will save the command into the event store and then call the method that is going to mutate the state. And it will actually handle that on a stack, so that if you have multiple persists throughout the system, it actually bubbles up and works correctly in more complex scenarios, which is why you should be using that method. And on the internal one, we can just do all of our state mutations for this actor. And this will all replay correctly, right? Because there's no persist in the internal one, there is a persist in the command one. Snapshotting, you have full control over how you do that. Here it's doing it every 100 messages. You can do it timed, there is a scheduler in there, so many things. And this is where the states, the grouped state objects are really handy. If I get a snapshot that is recovering from disk database, wherever it is, if I'm recovering from that, I can just cast to my state object and replace my state object, and I'm already good to go. So for the snapshotting scenario, that's why I group these things together. You don't have to, but it's a good idea. So you can already feel that these 2 stories, like the DDD world and the actor world, it actually fits together extremely well, because the event sourcing is actually the persistence model that is already in Akka.net. They both attempt to model code after how the world works, so that is a really good one. There is an event bus in there that will allow us to do the synchronization between our command side and our read side, and it is built for really high throughput. And this high throughput is not something to be underestimated, because the high throughput means you can easily have millions of actors on a system, because the memory overhead is only about 400 bytes in a release build, on top of all the fields that your actor has. So having a couple of million actors, even on a laptop, is not an issue at all. And because the messages are not being written and read on a queue that lives across the network, but they're passed around as object references when they're on the same system, that is also very fast. So throughput is amazing. So when we apply all of this, and disclaimer, none of this is production code, it's something I hacked together on a weekend. So please don't like put this straight into production, but it illustrates how these concepts match and how you can apply this to building a system like that. So the first thing I talked about is having aggregates. And I wanted them to be clean and Akka.NET free. You remember that, right? So, and I also don't want them to know anything about the way stuff are stored. So what I did is I made this interface, and you really don't have to, but having an interface for a lot of .NET developers feels comfortable, and we just have two methods. We have the check command. It's like, hey, I have this command for your aggregate. What are the events that are going to come from that? Right? And then we have the apply event method, which is like, hey, I have an event that has already happened on your aggregate. Can you please apply it to your state? Like, these two methods are what we are going to need for any aggregate that we build. And if we apply that and we make an implementation of this interface, it becomes actually quite straightforward. All of our data and all of the state that we have, that will get set through events, right? And because we make them into properties, that actually will be serialized correctly when we would serialize our aggregate and store it as a snapshot somewhere. Then we have our command side, and on the command side, in the check command, we are just going to check which type of command we're getting and handle accordingly. And we will, using IEnumerable and yield return is a very easy way to maybe raise more events from a single command, because that happens a lot. But all you're going to do in your command handlers is check the current situation. Are there already beers in my box, and does it have a shipping label? Yes. Then I can send it. Otherwise, the send failed. And then we come back to what I told you earlier, right? This is where that happens. So that does just that. On the event side, what we're just going to do is have pretty simple methods that take the data from our event, and that will set all the internal fields accordingly, right? It will update our state based on the events. And the cool thing is, I'm going to skip over the base class, because for these aggregates, you can actually write a pretty nice base class for your tests that allows you to do tests like this. And tests like this for aggregates are pretty amazing, because this test is as close to human readable as you can probably get with C#. If you use factory methods, you can still get rid of the news. But all your tests will look like this, and writing a test will always be approximately the same amount of work. It's like, given that on my aggregate these events have happened, when I queue this command, I'm expecting this event, right? Or this list of events. All your tests will look like that, and that will be pretty straightforward to do and write new tests. And the cool thing is, this is like a behavior-driven design test scenario. It's really close to what your domain experts will actually discuss with you, or when you're doing event storming and trying to model the business processes. These are the scenarios that are going to come out. And it's very easy to keep those tests in sync with what the business people want. You can even write this before you actually write the aggregate and have a proof that you're actually building what the people are asking, which is always the biggest problem for us software developers, right? So these tests, human readable without doing any Akka.NET. So if I want to wrap these aggregates inside an actor, that implementation is actually, you can make that generic. So what I'm going to do is I'm going to do a receive persistent actor. My persistence ID will be the type of my aggregate with the aggregate ID, and I'm done. So that's good. What it will do is it'll create a new aggregate when the actor is instantiated, and I will register the commands and events. But I will just have one apply event method, and if it's coming from the inbox, I'm going to persist the event first and then apply it. If it's coming from recovery, I'm just going to straight up apply it. And if I recover from a snapshot, I just replace my aggregate, because that was serialized with all of its fields into the database, and that's going to come back. We can just replace it. And on my aggregate, I can just call the apply event method for every event that is going through the system. And for the commands, what I'm going to do is I'm going to call the check command method on the aggregate, get events back that have not been applied yet. And for those, I will persist them and apply them. And that way the aggregate is mutated completely. This context.system.eventstream.publish thing, I'll get back to that a little bit later in the presentation. How much time do we have? About 10 minutes. I can do that. That's okay. So that is our aggregate actor. So every aggregate that we want to spin up as an actor inside of our actor system is just going to need one of these, and it just needs to get implemented like that. We just inherit from that base class, give it the aggregate type, and we're done. So now you have a generic way of persisting and maintaining aggregates in your DDD system. That is your command side, right? This is the entirety of the command side. We now have an event-sourced way of handling commands and raising events from them. Now if we put it together into a little bit of a bigger structure, this is what our hierarchy would look like. We're going to have a command router where all the commands that go into the system come in. We're going to have an aggregate manager with all the aggregates underneath, and then we're going to have the read side and the integration side of our system. And I'll dive into that in a little bit more detail, but that is where our aggregate actors are going to live, and we're going to have one for each aggregate instance, right? Now the responsibility of the aggregate manager, it will be an actor that does only a couple of things. When you send it a connect request for a certain aggregate type with a certain aggregate ID, it will check if its child for that aggregate already exists. If not, it will create it, and it will give you back the actor reference to talk to it. It's the only responsibility. Now the command router, that's going to take in all of the commands that come into the system. And it will just send a connect request to the aggregate manager if it hasn't talked to this aggregate again, and then it will forward the command onto the right aggregate instance. And this is your thread separation. This one will actually take care that all of the commands get handled on different threads, because all of these aggregate actors, they can get scheduled on different threads on the thread pool. Now the command router may become a bottleneck, because it's a single actor that handles the entire command stream. And once we queue more commands than that this actor can handle on a single core on your CPU, you're going to have an inbox that overflows. It's something we can deal with. Comes back in a couple of slides. I can get to that. But it might become an issue. And that is one of the things that you always have to design for when you're reasoning about like single actors that may become bottlenecks that take like a huge stream of messages. And then here we will have projectors. And the projectors will be the actors that are responsible for taking the events that come from the aggregates and using them to update the read storage. And the read storage, you can build a read API on top of that if you want. We will have one projector for each read storage update action that we want to do. And then we have integration with outside systems. You're going to subscribe to messages from outside systems or events that happen. I mean, there's so many things that have to go from your system to other systems and so on. You can create actors for that based on the internal event stream. You're going to publish stuff out. Stuff that comes in will get routed to the command router on that side. And that will go into the aggregates in that way, right? But it's good to have like a good place for all these integrations. Now I've talked about the event bus a couple of times, and that's the magic that's going to happen between your aggregate actors and your projectors that are going to update the read storage. So on the command side, you already saw that context publish thing, the code that you see on the top left. You can do this from outside of the actor system straight into it, or you can do it from actors themselves. And all we do is we can publish any object to the event stream. And on the subscriber side, all we can do is when pre-start is a method that you can override on every actor, and it will actually run before the actor starts doing anything, even before it recovers its snapshot. And it will subscribe to the event stream, and it will give you the type of messages that it wants to subscribe to. There are no more filters than this. So design your event types on that bus accordingly to make sure that that does not become a problem as well. And then they will come in on your projectors, they will update the read storage. There's not much more to it than that. Now I told you that the command router might become a bottleneck, and the way that we deal with that is with routing groups. Routers are actors that are actually more actors acting upon a single inbox. So it's one inbox, multiple actor instances, and you can either create them yourselves, and then you're talking about a routing group, or you can have the router create its own routees, then you're talking about the pool. It's more of a technicality, and you can use a whole bunch of routing strategies. You can either do round robin or route towards the one that has the smallest inbox, or based on a consistent hashing on your messaging so that the same aggregates messages go to the same routee. That is a strategy that would fit the most in our design. But creating a router, you do that when you create your actor by editing the props and adding router capabilities to it. This will just create 5 instances of our command router actor and round robin between them. And it doesn't change the implementation of our command router one bit, which is very powerful. So let's wrap things up, because I think I have 3 minutes, right? Cool. So in short, our aggregates go into actors, our projectors go into actors, our integrations go into actors, all the commands are messages, all the events are messages, and the event sourcing is already built in, right? And that sounds oversimplified, but I really do think that DDD and actors are actually a fantastic match when you're implementing these systems. It goes very frictionless. Now there are so many things that I didn't get to in this talk. For instance, you might want to publish your event stream for your UI to consume. You can do that over SignalR. If you're going to configure actor systems, you're going to need a language called HOCON. Yes, exactly what we needed, another configuration language. It looks like JSON, but it's not, so that's amazingly confusing if you use both. It stands for Human Optimized Configuration Object Notation. Yes, I know, I memorized that. We didn't talk about how to set up clustering. That takes a little bit of effort as well. You might want to log stuff. Phobos is the only paid component in the entire Akka.NET ecosystem. It is a monitoring tool. It allows you to monitor like memory pressure, inbox sizes, how many things are happening, that letter queues, all that sort of stuff. It's about $4,000 a year for your entire organization. So if you're building anything meaningful with it, it's not going to be your biggest cost, and it's definitely worth getting. Newest version does support OpenTelemetry, which is pretty amazing. It plugs straight into Honeycomb or whatever you want to use. If you want to start learning, there's a great bootcamp on GitHub. There is a gold mine of information on the Petabridge blogs. Aaron does not like explaining things twice, so whenever he builds something new into Akka.NET, he blogs about it. This is one of the only products where I usually find more information on the blog than on Stack Overflow. So it's pretty good, it's worth checking out. They do offer paid training, remote. The training is awesome. It's usually the people who are actually building Akka.NET that are teaching the workshops. So if you're actually getting into it, it might be worth to get in touch with Petabridge. I'm not affiliated with them in any way, but they are pretty cool people. My name is Hannes. I'm the head of learning and development for a company called Access in Belgium. This is my Twitter handle and my ICQ number. I'm trying to make ICQ great again. And I'm a Microsoft MVP since a couple of months, so I'm really proud of that. That finally happened. I think I'm going to vacate the premises so that the next speaker can set up. But I'll happily take all of your questions in the hallway. I'm just wondering, Stacy, are there questions online that we need to deal with?
No, we don't have any questions online. There is one question from me that I would love for you to answer if possible.
Yes.
That was a whole load of resources at the end.
Yes.
Can you put those online somewhere so that we can find them?
Okay. I'll screenshot the slide and tweet it in a minute.
Awesome. Thank you so much.
Is that okay? Does that work?
Yep, that works.
Okay, cool. Thank you so much for being here. Let's do the questions in the hallway so the next speaker can set up, right?
Thank you very much to